Okay, good morning. So last time we continued our discussion on combinatorics under the title of combinations. If you remember, when we are dealing with items in which order matters to us, then we are dealing with permutations. If not, if the order does not matter to us actually, then we are facing a combination problem. Yes, for example, if I want to choose 3 people from a group of 10 people, the combination is just important for me, that they don't have any specific role, I am facing a combination problem. But let us say that I have 10 people, I want to choose 3 of them, but I want to assign them to different roles, one of them to be the boss, one of them to be the vice chancellor or whatever. In that case, even though I still want to choose, but because I want to assign different roles to them, not only the choice matters, but in which I arrange the posts, the jobs to them also matters. Yes? So that is why, so you need to have a good understanding when the problem is a combination problem, when the problem is a permutation problem. But I gave you some examples last time that even though the general problem is a problem in which order matters, but still the idea of combination helps us to solve the problem. Okay? So, and then of course we had formulas last time. 2 formulas you might need to solve this problem. One formula is that the permutation of r distinct objects. We have n distinct objects. We want to choose r of them and arrange them. Order matters. So the formula which you will find in formula sheet is this one. Then I also proved for you that if you are interested in the number of combinations, we proved this, that this only differs by the previous one by an extra factor of r factorial in the denominator. Yes. And I also told you that this symbol is common, but the most popular symbol is probably this one. So when you see this in the book, this means exactly the same thing. And then how do you read it? You read it n choose r. So this combination, this symbol is read n choose r. Okay? So I want to wait a little bit for you so that you can do these problems. For example, in the second problem, you don't have to know anything about the meaning of P's and C's, but what you need to know is just the formula. But in this problem, this is a conceptual problem, so you really need to understand how to proceed. So I will give you 5 minutes, 6 minutes, something like this, to think about them. We start solving them, and then we continue the lesson. Okay, so how's it going? So consider the set A from 1 to 12, one step at a time. How many 8-element subsets of A are there? If I just stop there, how many 8-element subsets of set A you can write down? I hope that you understand this is a combination problem. Why? Why it is a combination problem? Yes, because when you choose a subset, it doesn't matter in which order you write the elements. The combination of the elements matters. So this means that this is a combination problem. Okay, if I stop just there, how many 8-element subsets of A are there? It means that you are facing this problem that you have 12 distinct objects. You just want to choose 8 of them, and order doesn't matter. That's an extremely simple problem. The answer is choose 12 and 8. Yes, of course you can put it in the formula and calculate. But now it becomes a little bit more interesting because you have something coming after that. So how many 8-element subsets of A do contain at least 4 elements of this set? Okay, so how do you interpret the word at least? So on the one hand, you want to choose 8 elements from this set, but you have to choose it in a way that at least 4 of them are from 1 to 6. At least 4 of them are from 1 to 6. It means that either exactly 4 of them are from 1 to 6, or exactly 5 of them are from 1 to 6, or exactly 6 of them are from 1 to 6. There is no other options because there is no more than 6 elements here. Of course, then you have to see that what happens to the rest. Yes? So you can solve this problem saying that one scenario is that I exactly choose 4 elements from here. So how can I do that? I have 6 distinct elements. I want to choose 4 of them. So it's a combination problem. So it's a very standard one. So you just write 6, 4. Okay, but the problem is not finished, because if you just choose this and don't do anything, you haven't still constructed your 8 element subset. So that's a stage 1. So I would say stage 1 is to choose 4 elements from here and 4 elements not from here but from there. Yes? Is that right? So what? So it means that this is a stage 1, and then multiplied by stage 2. In how many ways I can do stage 2? No, that is the common mistake. If you write 8, choose 8, 4, I don't know how many of you have written this, but I hope that you agree that this is not correct. Because when you, I don't know, how many of you have written this for the first part? Yes. This is not correct. Can you see why? Because when you say I choose exactly 4 elements from, this is the step that I am calculating in how many ways I can exactly choose 4 elements from here. Okay? But when you say, okay, I choose 4 elements from here, so far so good, and then you say that, okay, there are 4 more elements that I want to choose, because in principle I have to choose an 8 element subset, then you say that, okay, 4 of these elements I have already used, then from 12 of them, 8 of them are left, so then I choose 4 from those 8. But that's not correct. Why? Because then you are giving the opportunity to another number from this set to be chosen. Let us say that in stage 1, you chose 1, 2, 3, and 4. Let me write it like this. Let us say you choose this one. And then for the second one, in your head, you are eliminating only these 4 elements, okay? And then you say that the elements from 5, 6, 7, 8, 9, 10, 11, 12 are left. So I choose 4 from here. But if you say 4 from here, in some of those combinations, you also choosing 5 and 6. And then in that case, in total, you have 6 elements from that. So that is a common mistake. So you have to write it from 4 from 6. So because if you write 4 from 8, you are giving the chance that 2 of those numbers that are within B be chosen again. But we don't want to do that. We want to find the number of ways that we can exactly choose 4 elements from here. Okay, but this is not the only option, because or this time I can choose 5 elements exactly from here. So it becomes 6, 5, 6 choose 5. And how many elements I have to choose from here? 3, because in total I want to have 8 elements. But I should write 3 from where? From how many? 6 again. Yes? Is that right? Because you see, the first step allows you to choose 5 from here. So it means that you want to choose exactly 5 elements from here. You did that. It means numbers, for example, you choose 1, 2, 3 up to 5, but then you are not allowed to choose 6 again, because if you choose 6, then it means that you have 6 elements from here. You want to have exactly 5 elements from here. So when you choose 5 elements from here, no matter which one you choose 5 of them, then the whole set should be gone. And the leftovers, you have to think about what is left. So then you write 3 from 6 again. Is that right? And then, is this the only scenario? No, because I can choose all of them from here, which of course, what do you expect for this number to be? 1. Because if I have 6 elements and I want to choose all of them, there is only one way, choose all of them. And then how many is left for me now? 2 more from how many? 6 again. Okay, so that is the answer. Is that clear? So this problem was good because that is a common mistake. Usually people think that, okay, we have to choose 4 from 8. That's not correct. Okay, so this problem, you can solve it actually. It's not hard. Let me also give you a trick. Okay, we will come back to it later. So let us keep it like this. If you want, you can continue and calculate this, but that is enough usually for the exams. But I want you to understand why we multiplied and why we added. Is that real clear? Okay. But this problem has nothing to do with counting. It's just algebra. Okay, so you want to find or solve this equation. Solve the equation means find this missing n. The only thing that we should supposed to do is just to use the formulas up there. So for example here, n is the same n there, but 4 is playing the role of r. Here the same, but here 5 is playing the role of r. So just I put the formulas here. So let me write them here, then I continue there. So it becomes n factorial. I am using the left side formula. And then the difference between them, n minus 4 factorial. Plus, the second formula is the right one. So it becomes n factorial, the difference between them factorial, but this combination has an extra factor of r factorial. R is 4 in this case, so it becomes 4 factorial. Yes? And then what happens? On the right-hand side, I have 25, and then I have to write something for this. So it is the n factorial in the numerator, the difference between them, factorial in the denominator. Because it's a combination, I also have an extra factor of 5 factorial there. Okay, so that's it. I have to find a way to solve this problem. Do you have any ideas what to do? Yes? That's a very good idea, yes? So let us follow you. So you are saying that factor this thing out. So n factorial, n minus 4 factorial. I am pulling this expression out. So this is pulled out completely. So what is left is 1, because when I multiply it back, I will get the first term. And what plus, what is left from here? This is pulled out, this is pulled out. 4 factorial is left there, so it's 4 factorial. Okay, and on the right-hand side, what do I write? I just write 25. Okay, n factorial is, we can simplify n factorial. I mean, it is better to simplify this n factorial by that n factorial. So if you don't mind, let us not change anything, and let me copy and paste this one as well. And I have a 5 factorial. So 5 factorial, let us keep it for the time being. It doesn't matter if I write 5 factorial on the left or on the right. But the reason I did it like this, because I can divide by n factorial, and this is plausible because n factorial is never 0. So I am on the safe side. Be careful. If you want to divide, you have to confirm that what you are dividing by is not 0, which is in this case is guaranteed. Okay, and then what can I write for n minus 4 factorial? By looking on the right side, I realize that if I write it as n minus 4 multiplied by the previous number factorial, what's the previous number to this? It's a number which is 1 unit less. So 1 unit less is n minus 5 factorial. Why this is good now? Because now this n minus 5 factorial from this side and that side are gone. Okay, so let us try to simplify what is left. I divide by n factorial, 1 is left, and then n minus 4 is left. And then this is 1. I don't know, 4 factorial is what? 1 times 2 times 3 times 4 is 24. On the right hand side, what do I have? I have a 25 in the numerator. And 5 factorial is also, I don't know, 5 times 4 times 3 times 2 times 1. Okay, so that is just a simple algebra. So if I take the common denominator, it becomes 25 over 24. So it's 1 over n minus 1, 25 over 24. And then on the other side, you have 25. If you don't mind, let me just write it as, I don't know, yes, 120. Let us make it simple. It's not that hard. And then 25 and 25 are gone. 24 and 2, this is simplified, I get 5. So anyway, what is left on the left side is 1 over n minus 1. On the right side, I have 1 over 5. So then it means that n minus 1 is 5. So then it means that n is equal to 6. Yes?
Why is it n minus 1? Was it n minus 4?
Ah, yes. Thank you. Yeah. Whenever you see this mistake, just tell me immediately. So that's my bad. N minus 4. Thank you. So what is the answer now? 9. By the way, is 9 acceptable here? Yes, because this number sitting here should be greater than or at least equal to this number. So the minimum value for n should be 5. So we are on the safe side because I got n equals to 9. Yes? Any questions? No. Okay. Now let us continue. Now that we worked a little bit with algebra, let us try to talk about two very important identities here. One of them even carries a name. Okay. So the first one doesn't have any names. So if you have this symbol, n choose r, this is always equal to n choose the difference. Yes? It's a very important thing to remember. For example, you don't need to calculate. So for example, 12, 5, if 12 choose 5 is always equal to 12 choose 7. So if these two numbers add up to the number on top, they have to be the same. Okay? I don't know. For example, 180 is equal to what? 100 choose 20. Okay, so that's a good thing to know. But we can prove it in two different ways. One is algebraic way, and the other one is cooking up a story. So that's a storytelling proof. And I told you that in combinatorics, that's a very important and powerful tool. So let us say, instead of working with letters, can you cook up a story to see why this should be true? 12 choose 5, 12 choose 7. Why they have to be equal? Anyone else? Yes? You come up with a story. Yes. What is your story?
The amount of ways you can choose a certain type of marbles is equal to the amount of ways you can choose not to.
Okay, so that is your story, but make it more tangible to others. Let us say I have 12 students, yes? And then I want to choose 5 of them for a project. So in how many ways I can choose 5 students to do a project for me if there are 12 students? The number is 12, 5. And that is the way I choose the students. I say, come with me. It's a little bit weird, but it is also possible to choose those people who are not supposed to be in the project. So it is not common, but it is possible. So I have a list of 12 students in front of me. I say that, okay, the people who I read, yes, are the people I want to join me for doing the project. And I read 5 of them. Okay, this is more natural to humans, but otherwise, that's also possible. I would say that, okay, the people I read, their names, how many of them are there? 7. They are people who are not supposed to be in the project. So it means that the number of ways I am choosing 5 out of 12, it should be the same as if I am choosing 7 out of 12. Yes? Because immediately when I choose 5 out of 12, I already chose 7 out of 12 as well. Is that right? Yes. So that is not weird that choose 12 choose 5 should be equal to 12 choose 7. And this is in total. If I have, in general, if I have n students, I can choose r of them for doing the project. It automatically means I am excluding those other students to not do the project. If I choose r of them to do the project, how many of them are not supposed to do the project? N minus r of them. Okay? But if, of course, you can immediately prove this using the formula. So let us start from the right-hand side. It's always good to see both of them. Okay, so the left side No, the right side is, let me start with the right hand side. So I want to use the formula top on the board on the right side, and then I want to write something for this. How should I write it? Look at this formula. Yes. So n is still n. So I just put n here. Okay, n factorial in the numerator. But can you tell me what should I write for this r factorial? Yes, because n minus r is playing the role of the number on the bottom, yes? So it becomes n minus r factorial. But then what should I write? N minus r. You see the formula is n minus r. N is n, but n minus r is playing the role of the new r. So it becomes minus n minus r, whatever it is, factorial. Yes or no? Okay. But then what happens? The numerator is still n factorial. The denominator, I cannot do anything with the first term. But can I simplify this one a little bit more? Yes, just multiply the minus sign in. It becomes minus n plus r. N's are cancelled, r is left, so it becomes r factorial. And I hope that you agree with me. This is exactly the formula for n choose r. Of course, it doesn't matter if I write it in this order or the other way order because it's a product. And that's exactly equal to the left-hand side. That's algebraic way. Okay, but let me ask you another question. We want to solve it in two ways. So this is one of those identities. I want to somehow remember it. Okay, it's always useful for these kinds of calculations. For example, let me ask you one question. If I ask you, what is 12, 11? Can you do it very quickly? Why? Because 12 choose 11 is equal to what? 12 choose 1. But what is the meaning of 12 choose 1? It means that I have 12 people, I want to choose one of them. In how many ways I can choose one from 12? 12 ways. So you see, so sometimes it helps the calculations, or I can do the calculations faster. Okay? So instead of doing that. So for example, yeah, that's good. But let me ask you another question. So you can solve it in two different ways. The algebraic way for this problem is not hard, but a story is a little bit hard. I see that if you want to come up with a story. Okay, so the formula is this. N choose k is equal to n minus k plus 1 divided by k, and then I have n k minus 1. Okay, so let us say that k's and n's are in the appropriate limits. So say that k is at most equal to 1, n is at most equal to n. Okay, so let me see if that's correct. I wrote something here. N choose k, yes, that's correct. I mean, if you are asked to do this in the exam, you can do it algebraically. And I intentionally wrote it as a fraction because fraction and a story is not compatible that much, because we want to count the number of things, and this is a fraction. Okay, I want to see how many of you can come up with this story. Okay, but I would insist that everyone should be able to do it algebraically. So in algebraic way, it's not that creative. You don't need to be that much creative to do it algebraically. So you can start from the more complicated side, use just that formula on the right side, simplify this little by little, and then come up with this answer. I'm not underestimating this method. This is also valuable, but it is not fun. The fun part is just telling a story, and the reason is clear because we like stories, yes? Okay, so I'll wait for you a little bit. Okay, if you are interested in storytelling, don't think it in that way. Think this problem instead. Because fraction, I intentionally wrote it like this because I want to give you some experience of this kind of thinking. Because in storytelling, we are counting something in two different ways, and then probably you don't know how this fraction comes into the game. But you don't have to work with the fraction. You can prove this one. Do you agree? If you are able to come up with a story that guarantees this equality, then going from this equality to that equality is just a matter of dividing by k. So to get rid of this fraction in your story, the reason I just gave you this hint because I want you to be able to think and still come up with the story. The story is not that trivial. You need to find a nice story for it. I mean, you know what I mean, yes? You set up a counting problem and you count the same thing in two different ways, okay? And then they have to match. Okay, another hint, if you want to solve it using storytelling, this is the story for n choose k is very simple. I have just n students, I want to choose k of them. But think in a way that how you can bring this k into your story. So you need to cook up a story in which when you count it, then this k somehow appears. Because the story of this is very simple. I have n students, I want to choose k of them. Of course, it will give you n choose k, but the problem is that how can I deal with this extra factor of k? If you concentrate on this in your story, then you might come up with an idea, how can you bring in this factor of k? You want to say something?
Maybe if like repeat the process k amount of times.
Okay, this one is one way, but then you have to have a very established scenario so that you can count, you should be able to count it in two different ways. One way gives rise to this number, the other way gives rise to this number, but then of course they have to be equal because you are counting the same thing in two different ways. Yeah, but these are vague stories. Yes, your idea is not bad because you see that on the right hand side one person is gone. So you have to come up with your final version of your story. You have to edit it. Okay. But the people who are working in algebra, doing it algebraically, they shouldn't face that much problem. I'm not saying this problem is as simple as the previous one algebraically, but it is very manageable. So first of all, you want to prove something, an identity, equality. So it means that it's always better to start from the complicated side to do simplifications and reach to the other side that is simpler. So in this case, hopefully you agree with me. Still, again, it's better to start from the right-hand side. There is nothing I can do with it, so I just copy and paste it. But there is something I can do here, and that is using the formula. So the formula is up there, n is n, so it becomes n factorial. K minus 1 here is playing the role of r in the formula. So it becomes k minus 1 factorial. And then the difference between them. The difference between them should be visualized in that way. But when I multiply the minus sign in, what happens? It becomes n minus k, but plus 1, and then I have this factor. Very simple, yes? Okay, so then how should I continue? Isn't it simple? So how should I continue if I want to do it algebraically? Yes? Yes, these two will be multiplied, and the combination, this is k minus 1 factorial multiplied by the number coming after it, meaning k. So this is simply seen to be k factorial. Yes? But this one, how can I write it? Because I see this factor up there, this is without factorial, this is with factorial. So then I use the same old trick. Yes, what do? I write this number, whatever it is, multiplied by the number previous to this factorial. What is the number previous to this? Whatever this number is, 1 unit less, and then factorial. Agree or not? Yes? Everyone happy? Yes. So what happens now? This is in the denominator, this is in the numerator, and these are common factors. So this one and that one can be simplified. So 1 is left here, 1 is left there. So 1 will be multiplied by n factorial, so which becomes n factorial. And then k times this was k factorial. And what is left for me here is n minus k factorial. Do you agree? Okay, but what is this one? That's exactly the formula for n choose k, because that is exactly the same formula you see up there, but r is replaced by k. So the answer becomes n choose k, and n choose k is equal to the left-hand side. That's one way. Yes? Okay, but let us talk about a story. So the story should be n, for example, n people involved, I want to choose k of them. That is for sure, it should be one part of my story. But to give the role of this k, what do I say? I say that I also have a job. Okay, so let us say I want to choose one of these people to be the boss. So I not only want to choose 12 people, okay, 11 of them are on the same level, but one of them is supposed to be the boss. And this will solve the story, and that's my story. So my story is this. I want to choose k students and choose one of them to be the boss. That's my story. So that was the modification you just need to add to your story. So let us see how it works. Let us solve this problem. That's exactly this problem. How do you do that? I have n people in front of me. I want to choose 12 of them and assign one of them to be the boss. In how many ways you can do? You can say stage one, I choose my people, regardless of the job. Yes? How many ways I can do this? I have n people, I choose k of them. Now I have a gathering of k people in front of me. And then I want to, stage two, assign one of them as the boss. So in how many ways I can do a stage two? K. Because I have k people in front of me, I want to choose one of them to be the boss. In how many ways I can choose that person to be k? Yes? Is that right? So the number of ways that I can choose k people and assign one of them to be the boss, give the boss role to one of them, is this one multiplied by that one. This is one side of the story. Yes, at least I was able to come up with that number on the left. But now you have to keep the same story, but count it slightly differently in a way that the second method gives rise to this combination. And then, of course, because you are doing the same story in two different ways, then, of course, the answers should match. Okay, I did one part. I'm waiting for you to do the second part for me. How you change your algorithm so that you still count the same possibilities in the first story, but in a different way that you can come up with that number. Yes?
So if you first choose all the people that are not the boss from the so k minus 1 people, and then after you picked everyone who's not the boss, then you pick the boss from the remaining people.
Yes, exactly. So I think I agree with your story. So what you are saying is that so here I chose the people first, and then from the people I chose, I assigned one of them to be the boss. But what Melvin said that, okay, what do you do first?
Choose everyone who won't be the boss. So n choose k minus 1.
Everyone is not the boss. So let me see if I can understand your story.
First you choose the 11 people. If you're supposed to have 12 people, one of which is the boss.
Let us say, yes, if you have 12 people, I want to choose how many of them? This is the story. Let us say that I want to choose 5 of them, and one of these 5 should be the boss. So what I can do, I can choose 12, 5. This gives me the people, and then I have 5 people in front of me. I can assign this job to one of them, so I can do it in 5 different ways. This is the left side of the story. Okay, but now what is your right side of the story?
So then you first you choose.
No, again, I have 12 people in front of me. How do you want to choose this?
So then you choose 4 people.
4 people out of?
Out of 12.
Out of 12. Okay, so you say that I choose 12 Okay, yes, I agree with you. So it means that because I know that one person should be the boss, so I don't choose 5 of them. I choose 4 of them. These are the people that are not supposed to be the boss. Okay? Is that right? So how many peoples I have now in my team? 4, but I know none of them is going to be the boss. Now I want to choose the boss. How many options I have to choose the boss? 8. Yes, I have to multiply it by 8. Is that right? But I want you to understand that you are counting the same problem again in a different way. In this strategy, I chose 5 people. Now 5 people are in front of me. I assign this job to one of them. But I can say that, okay, let us choose 4 of them. Then I have 4 people in mind. I don't want to give the boss role to any one of them. So these are the people who are not going to be the boss. I have 4 people in my team. But I want to choose 5 again, and that person should be the boss. Then from what is left, I go and pick one, but that person that I am picking now is my boss. Yes? Do you agree? These 2 numbers should match. In general, that is exactly what we did here. So what we are doing is that I choose k minus 1 from those people, but none of them is going to be the boss. So how many people are left? There were in total n. I have chosen minus 1 of them. The difference between them is left. But the difference between them is what? N minus k plus 1. And that's exactly that factor. Okay? So now if you see, this story is very nice. So you come up with a story that you can see that without even doing any analytic work, you can come up with the idea that these 2 numbers really have to be the same. Okay? Now you have a little bit of experience in storytelling. Then I want to continue with the second identity, which is in the book and has a name, and that is called Pascal identity. Yes. So this is in the book. This one that I also want to write, it is also in the book. This was not in the book, but it can be. It's conceivable to be in the exam because I don't expect you to do it by storytelling. I should able to. I would expect you to be able to do it algebraic. Okay, so the second identity is the Pascal identity, which is a very famous identity in combinatorics in the topic of combinations. So n choose r is equal to n minus 1 choose r plus n minus 1 choose r minus 1. Of course, because r appears here, the maximum threshold for r should be n minus 1. So, and then because r minus 1 appears here, the minimum value for r should be 1. Because in principle r could be 0, but in this problem r cannot be 0, because if r is 0, I will be in trouble. I will get a minus sign here, minus 1 here. And then in principle r can be maximally n, but if r is n, then this number is bigger than that number. This doesn't make sense. So I have to respect these limitations. Under these limitations, then it means that this is valid. Again, the book is only concentrating on proving this algebraically in one of the exercises, but you can come up with the story again. Storytelling is very fun thing to do if you like these kind of ideas. Yes, you don't need to do any algebra. Here, by the word algebra is complicated. So I want to give, not complicated, I mean more complicated than the previous one. So I want to wait for you. If you like, do it algebraically. If you don't like, come up with a story. The story I would say here is not hard. Even though the algebra here is harder, but I think this story is not that hard.